So I saw this pop up during the week. It's the Superstrata 3D printed carbon bicycle. They were doing a crowdfund campaign. They've that's sort of just come online in the last couple of days. It's been in the media. Um, is it a game changer or not? So let's have a bit of a look into some of the technical aspects and see where it goes. So here are some information links. You can follow those. Obviously, their homepage, their crowdfund campaign, a couple of media articles, and there's some videos up on YouTube where you can also have a look at some of this stuff for yourself. So they've got two different bike versions listed. They've got a pedal-only version, an e-bike version, and then they've also got some wheels which are up on their crowdfund page as well. So this is the pedal version. Let's have a look at some of the features on this and what we can see. So the first thing you notice is that it doesn't have a seat tube. So seat tube is missing. The next thing you sort of see is that the lines are actually quite, I mean, they're quite sleek. It's quite a nice looking bike. It's quite boxy. You are a little bit limited in your seat height adjustment through there. Obviously, your seat post needs to be the right sort of length. Overall, you've got some standard components. Looks like it's a disc brake on this one, through axle. Look, they're saying Shimano gears, just flat pedals here. So I suppose I don't know why future bike designers, or they always sort of look at concept bikes, they always take the seat tube out of it. So by taking the seat tube out, you're removing the major axis basically from the triangle. So by having the triangle, like that section triangulated, gives you much more control over its mechanical properties. So anyway, that's what they've done. You'd like to think that they've done enough modelling, and I mean, they may have done that to get a bit more comfort out of the bike. Yeah, only the designers will really know that. But I mean, overall, it's not a bad looking bike. So here we have the e-bike version, and the first thing you'll notice on this version is it looks pretty much exactly the same as the pedal-only version. The down tube is not any bigger to store a battery, like as is sort of typical. It's black, as the other one was white. I don't know if you're going to have a choice on different colors or what. It's got the different wheels. They've got two different wheels. I'll talk about those in a minute. It's got the different wheels in it. But on this version and also the other version, the one thing which sort of stood out was that you don't see any cable routing. So where the gear cables, typically you'd have if it's mechanical, you'd have a piece of outer housing, sort of like that, or even if it was Di2, Shimano, because they said they're using Shimano, so it's not wireless. It's there's no cable routing, and you don't see any hydraulic lines for the brakes. So yeah, but you have to remember these are renderings. They're not images of the actual product. These are basic a computer drawing of what the product would look like. So I don't think they've actually got product that you can physically see in these images. So there is a cable going from the handlebar into the fork, or into the stem and interface up through there, and but then you don't see any cables anywhere else. So the other talking about the the seat tube in the other slide, the other thing of note is that there's nowhere to mount a front derailleur. If you want to run a front derailleur, you can't run a front derailleur. So it's purely one by at the front. So that does limit your gearing a little bit. Probably not such a big deal on the e-bike, but it depends on what sort of riding you do. So yeah, let's have a look at the wheels. And the last product is the wheels. So they've got two different versions of wheels. Now, for the life of me, I don't understand why you'd make a spoked wheel with like this section, how you've got these cutouts. It makes no sense, because you're putting more material in there to get the stiffness. Instead of making a larger hollow section, you got more material. You've got more drag from an aerodynamic point of view. Yeah, it makes no sense. So it's purely an aesthetic reason. I don't know what the weight of them are. They say they're light, but they don't say how much they are. So, and they say they're very strong. The other version has got different spokes, and they're running some sort of, like, they've got the color, a yellow sort of color inside, and sort of beam type spokes or arm type spokes, similar to the old spinagey sort of design, which, well, we know how successful that was. So yeah, so I'm not sure about the wheels. Yeah, no, I'm not sure about the wheels. I don't think that's such a good idea. So they're calling it the Unibody for your body, introducing the world's first true unibody, completely custom fit bicycle, 3D printed in continuous carbon fiber composite. So what are the claimed advantages? They're saying superior strength to weight, 61 times that of steel, 15 times titanium, a custom fit. You've got no joins. They're saying no bolts, glue, any joins anywhere, no splinters. They're even talking about splinters. Wow. Less weight, unprecedented impact resistance, low void content, less than 1%, and no human error. So let's sort of run through these a bit more. So superior strength to weight, they're saying 61 times that of steel for the weight, but the claimed frame weight is 1.3 kilos, which for a frame is actually, it's not that light. So I mean, you can get a steel frame that weighs that. You know, some of the high grade steels are definitely in that region, and titanium, etc. So yeah, so it'd be interesting to see some data on that, some actual data. Yeah, the custom fit, I'm sure they can do a whole bunch of different sizes. They're obviously not limited to molds like conventional carbon molding, you know, jigs or anything like that. You know, no joins. Well, you know, that can be an advantage. Although a well-designed joint is not that much of a limitation either, necessarily. Saying less weight, but yeah, I'm not sure how they can sort of say it's less weight when it's heavier than a lot of other bikes. Unprecedented impact resistance. Now, this could be true. The thermoplastic material, the thermoplastic composite material, typically has got very high toughness. So, and the fact that the frame is quite heavy, it might actually be really rugged and really solid. The low void content, they're saying less than 1%. The I read their white paper, and they had micrographs and things like that, and that may well be the case. But they've got more resin as well. So yeah, I'll talk about that a bit more of that in the slides coming up. And no human error. So it's all made by robots and lasers and things like that. So no problems with that. Now, one of the concerns probably with all these sorts of things is they don't actually show you the real product. They show you a computer model of the product. So that there's some limitations in that. So it'll be interesting once we actually see some real product to do some actual testing on their strength claims and weight claims, impact, etc., and see how that actually plays out. So here are a couple of quotes which I noted, reading all their stuff, and the first one is by a former Olympian and world record holder on the velodrome, that his race bikes were light, but they would crack when pushed too hard or crashed. Having a bike that's light like other carbon bikes, but really tough, is a dream come true. And I can imagine that would be, but however, I don't know, the bike doesn't seem particularly light, and also it's not the sort of bike that you'd ride on the velodrome with and race with. It's not designed as a race bike. It's designed more of a city bike, a commuting bike. So I just thought that was probably a little bit out of place, that quote. The other quote is that the project team has a working demo, not a final product. Their ability to begin production may be affected by product development or financial challenges. So what that tells me is that they've got some basic understanding of what they want to do, but they're nowhere near having production capacity, and that production capacity may change at any time due to financial constraints or technical constraints. So I thought both of those were should be noted. So let's talk about the material details. So in the documentation that I've been looking at, that they've published, there's on the Indiegogo presentation and on their website, etc. There's also a link to a white paper, so I sort of had a bit of a flick through that and tried to get some information there, and also watching the YouTube videos. So so let's talk about some of these things. So we've got the matrix, and it's a thermoplastic as opposed to a thermoset. Now, in most of the documentation, they listed the polyamide, which is a nylon, but in the white paper, they listed the PEEK, which is polyether ketone, which is quite a high performance plastic used in other composite applications. So I take it that in the bike they're going to be using nylon, the polyamide, and polyamide is it's a good material. I mean, it's been around for a very long time. It's got very good toughness, chemical resistance, etc. It can be degraded by UV, so that's probably one of the negatives. But overall, it's a great material. So particularly for its toughness and chemical resistance. The fiber that they've spoken about is the Hexcel AS4, which is a standard modulus fiber. Now that fiber's been around for a very, very long time, 30 plus, or probably even more, probably 40 years. Well-established fiber. There are higher performance fibers in that range now, so but it's an aerospace certified high strength standard modulus fiber. So certainly no sort of limitation with that. In the white paper, they spoke about the fiber volume fraction, and that was sort of a nominal 50%, which is a little bit on the low side. So typically with autoclaved, cured pre-preg, you're approaching 63%, depending on your fabric type, thereabouts. So for laying down basically bundles of fiber, 50% is probably a little bit low, but obviously that's related to the process that they're using and the deposition rate. So we'll talk about a little bit of that. Now, they did say they can go up to 100 millimeters a second, or 4 inches a second in imperial measurements. But on the videos that I saw, it seemed to be much slower than that, and it seemed to be, particularly on corners, that it was very slow around those corners. So I'd say that the 100 millimeters a second rate quoted would be on a straight section, but you're going to have limitations when you're going around corners or different fiber angles and things like that. Now with porosity, they did in the white paper and also on their website, they had a micrograph showing that the porosity was less than 1%. So yeah, I mean we have to believe that, and if that's the case, that's good. Having a volume fraction of 50%, so that means you've got more of the matrix. It is easier to reduce the void content because you've got more of the matrix to fill any potential void. So, but then that does increase the mass and reduce. You can reduce some of the other properties a little bit as well. So, but it's good to have low porosity. As we know, air is not very strong. In terms of the volume of manufacture, they're saying currently they can make that one machine can make 2 bikes a day, and they're hoping to, with the latest development of machines, that they can make 6 bikes per day out of one machine. They also said that the manufacturing was going to occur in Vietnam. So I don't know why they've chose Vietnam, but that's where the factory is planned to be. So some of the other information listed is they've only got 2 colorways, so it's white and black. So there's no custom paint or graphics or any of that. White or black is your choice. The MSRP for the standard bike is $2,799, for the e-bike $3,999, and for the wheels $1,699. So that's the full retail. Obviously, if you go with the Indiegogo now, then you'll get what is it? It's over 50% off on all those prices at the moment. So yeah, that's how they're doing it. They've got integrated lights built into the frame, and they've got other electronics which are available as an upgrade. So they're talking about having all these other little systems in as part of the bike. They say it's a master of all terrains. You can use it on gravel, on the road, off-road, etc. On the e-bike, the battery is internal in the frame, so you can't even tell that it's an e-bike. They're saying they've got 500,000 variations in sizes, though in terms of fit, as opposed to a standard model might have 7 different frame sizes. So that's a lot of combinations, 500,000. And they first went to Eurobike in 2018 to show off some of their technology, and they expect to ship production units in the first quarter in 2021. So some of the questions that I have, what about the fork? Like all the videos, they only show making of the frame. Now the fork is obviously a much more complex thing to make due to the geometry constraints and the loads placed upon it. So I'm not sure about the fork, how they're going to do that. The build plate required to print. Yeah, I'm not sure. I mean, I've done some 3D printing. Yeah, I just from my experience, I'd say that the frame would be much easier to do than the fork. The fork is going to be a bit more complex. There's no mention of the fork in any of the information that I can see in terms of, they're saying they're going to manufacture the fork, but there's no images of one. There's no information on how they're doing that. And this ties into the second point. How does the machine lay continuous off-axis fiber to make a tube? So with a tube, you need to wrap the fiber needs to be going around the tube. Now, if you're on a build plate, so you've got a flat plate which you've got to start off with. So the print head, as shown in the videos of their technology, the print head's running along their build plate. How do you get fiber around to complete that section to make a tube? So because they're laying the frame is flat. So how are you getting that hoop fiber around the structure? So that's a major question. Now, how is the surface finish achieved? Typically with thermoplastics, they're more difficult for paint, etc., to adhere to. There needs to be special treatments like corona treatments or plasma treatments and things like that, because their surface energy is so low. Now, the bikes that they've presented in their on their displays and things, they've obviously been painted. I mean, if they're having a white bike and also a black one, to have a white one, it's got to have some sort of coating on it, because carbon itself is black. Yes, you can use a white dyed nylon. However, the carbon is still going to be black, the fiber. So to make a nice white bike, it's got to have some sort of coating. So how is that achieved, and how is the surface finish done? Typically, the thermoplastic type composites, you can't sand them like you can a typical thermoset like an epoxy. So they've different processes. So you need to have it and as molded. And also the surface finish typically on a 3D printed is not a class A smooth finish. So so that's sort of another big question. Why is the frame relatively heavy if the process is superior and the material is so much stronger in their claim? So they're saying it's 61 times stronger than steel for the weight, and 15 times stronger than titanium, and I think there was another thing on aluminium, 50 something times stronger than aluminium. So why is the frame 1.3 kilos, and even aluminium and titanium frames and steel frames are lighter than that? So that's another question there. Being an automated process, the whole point of having an automated process is to remove the labor component, which is typically in Western countries an expensive that's the expensive component. So by automating, you're removing labour, reducing costs. So what I don't understand is if the labour is so low on an automated process, why is it being made in Vietnam, which is a low-cost labour region? That sort of doesn't seem to quite add up either. And then why do the wheels have that spoke design? I mean, I spoke about that a little bit before, but yeah, it just doesn't make any sense. And the geometry considerations. So, they're saying they can do 500,000 different sizes from being 1.5 meters tall person to 2.2 meter tall person. But if you're still running standard 700C tires and wheel sizes, that is often a bigger constraint, particularly for the small frames. Crank lengths and all these other factors which tie into the whole rideability and the handling of a bike, as opposed to, it's not whether you can just make a structure that size, it's still got to be able to be ridden and handled properly. So that's some of the other questions I have. So anyway, happy to hear your comments. Put the comments down below what you think. If you think this is going to change cycling, or is it just another example of vaporware, where the product is marketed and all the renderings are shown and all this sort of stuff, but to actually take it to market as proposed is a bridge too far. So yeah, let me know what you think, and we'll see you again soon. Okay, bye.